Hello guys, in this video we are going to cover HTTP 1.1 protocol. HTTP refers to Hypertext Transfer Protocol, and it is a protocol that it is used to communicate between a client and a server across the World Wide Web. So it works on a request response model. So there is a client and there is a server that serves a request. For example, if you are building an application, you will be creating a UI and a backend, right? So UI will be acting as a client, and your backend server will be acting as a server. So your client will make requests to the server and get data from it. So it uses HTTP methods that are get, post, put, that we will cover in detail in the further video, and it will use those methods to get different data from the server. So it's a stateless protocol. What does it mean? Stateless protocol means it does not maintain a state. For example, your server could be stateless and a stateful server, right? For example, if your server maintains a state, for example, let's say you are storing a user profile. So you have a login page, and whatever user login, you store it in a DB, their credentials and their info, basic info like name and all those things, right? So if you has that case, your server has a state, you have some state to maintain. So that is stateful. Stateless means it does not maintain a state, like every request is independent. So no request is dependent on another body or something, and every request is independent, and it's a stateless protocol. It does not maintain any state in it. So server does not retain any knowledge of previous requests. So if you made a request, for example, let's say there is a user and you want to edit something in it. For example, you want to edit first name. You made a request and the first name gets edited in the server. But you can make another request with some other name as well to edit it again. So server does not maintain any knowledge or any track of what previous requests were made on the data, and it will just behave in the same way and update the name again. So it does not have any knowledge of previous requests from the same client. Workarounds are like cookies, session, tokens, and they are used to manage state. So sometimes you want to manage the state as well. So there are cookies, sessions, and tokens that can be used to manage the state. For example, once you are logged into a server, for example, you have different servers, right? For example, if one of your server is in India, some is in another country. So Indian people should always go to Indian server, right? So they can maintain a session there. So once a session is maintained, whatever server is specified there, until that session is valid, user will always go to that server only. So I will create a separate video on cookies and headers. So initially HTTP started with 0.9. This was a very simple protocol. So in this only get method was there. So if you have worked with REST APIs right now, you see there are many methods, HTTP methods, right? Like get, post, put, all those things, right? But when the HTTP started with 0.9 version, only get method was available. Client was only able to get the data from the server. The communication was not two-way. So in the present HTTP methods, we can also send data through post calls, right? But in 0.9, this was not the case, and the only response was an HTML file. So mostly today we work with JSON, right? We just send JSON data, but back there the response was always HTML file. So HTTP 1.0 came and it expanded its methods to HTTP GET, from HTTP GET to head and post as well. So here as well, all the methods were not available, only head and post were added. Post was introduced to send message from the client to server, because in HTTP 0.9 client was not able to send any data to the server, right? To update anything or to do something like that. So post was introduced here, and from now the client was also able to send request body in the request. HTTP status codes were sent to indicate success or failure. So in HTTP 0.9, as only one method was there and this was extremely simple, there was no status code as well. So here status codes were introduced. For example, 200, 201. We will cover that in detail. The HTTP headers allowed caching, which improved response time, authorization, and support for different types of files. So caching was also introduced in 1.0, and it became more flexible as compared to 0.9. Then HTTP 1.1 came, which we are using nowadays a lot. So in this, there were many cache control headers came. So if you have used different headers while using REST API, you know there are various headers which maintain the cache, which tells the browser how to maintain the cache, like for how much time the cache will be validated, and if you want to revalidate the request or not. So there are different headers for different purpose. You can also set up a time limit, like after this time the data will get expired and you have to make a new request and not fetch it from the cache. There are different headers for different purposes. We'll cover that in a separate video. So new HTTP request methods were added. So here other HTTP methods were also added. So as in 1.0 there were only post, head and get, right? So here put and patch and options and trace, like all the other HTTP methods that we see now, they were added. Also here the improvement was in the HTTP connection as well. So once a HTTP connection was made to a server, it can also be reused for other requests, which was not the case in previous HTTP versions. With the HTTP host header, protocol was able to support servers hosted on different domains. So there was a header called host was introduced. So this header generally indicates, it just tells the server from which host the request is coming. So using this host header, we were able to support different servers which were hosted on different locations. Now let's look into the HTTP session. Following the client-server model, HTTP sessions are established using a TCP or UDP connections. So HTTP in the background, HTTP also works with TCP connection, right? It performs a TCP handshake while making a connection, and if it's working on UDP, then it maintains a UDP connection. So most of the REST API calls that you make from client to server, they use TCP connection. First the TCP handshake is there, then the request will be sent and the response will be received from the server. So we'll look into it. Client will initiate the connection in the server, optionally through intermediaries will acknowledge and use the same connection for transmitting and receiving data. So when clients make the request, server uses the same connection to send the response, like it maintains the connection. So when you make a request, you wait for some time and the response comes, right? So during that time the connection is maintained. HTTP session is a temporary information exchange between server and client, a sequence of network request response transactions that are initiated by the client using TCP or an alternative protocol on a specific port. So when a browser makes a TCP connection with a server, it makes some request response. There is an exchange of some request and response between server and client, and with a small amount of data transfer. So it just maintains a performs a TCP handshake and an SSL handshake if you are using HTTPS. So if you are using HTTP, by default the port that is used for creating these sessions is 80 or 8080. If you are using HTTPS, which is a secured protocol of HTTP, so it also performs a SSL handshake, and that is by default done on a port of 443. So let's look into how the serial connection in HTTP looks like. So in serial connection, multiple requests are sent sequentially over a server. Like instead of making the request in parallel, requests are sent sequentially. Like for example, once this response for a particular request is received, then only the next request will be made by the client. So this method is rarely used today because now browsers have become modern and they all support parallel request and everything. So this is not used by browsers by default nowadays. But this is what was there in the beginning. So if we will look into this diagram, let's say we are making two requests to the web server using a serial HTTP connection. So first a DNS lookup will happen. So client will make a request to DNS server. There will be some DNS server hosted somewhere, for example GoDaddy or some server. Then a client will make a request to the server to get the location, IP address of the actual server which we want to query to get the data. Once it gets the location of the server, it performs a TCP handshake with that web server. So a request will be made, and TCP handshake, a client will send a sync packet, and when web server receives the request, it will just send a sync acknowledge packet. Now client will again send the acknowledge packet to the server, and it will just say like I have acknowledged your request, and the connection will be made. After the connection is done, client will send the actual HTTP request which we want to make, like a get, post, or whatever request we want to make. After the connection is established, client will send the actual request. It will wait for some time, and after some time the response will be sent to the client from server. So once this all is covered, once the request is completed, then only the next request will be sent in the serial HTTP connection. So once the response is received by the client, it will make another request. It will make another connection, so because it's a serial HTTP connection, right? So this connection will not be reused in next request. So it will make another connection, same, it will send another sync packet, client will send sync packet back, and then it will acknowledge the connection. Once the connection is established, it will again trigger another request and wait for the response for that request. So this is how a serial HTTP connection works. There are no parallel requests made here. One request is made only if the previous request is successful, or when the previous request is finished, not successful. It can also fail, but once the previous request is finished, another request is made. In persistent HTTP connection, if it is serial, the same thing will happen. The only difference will be connection will not be made again and again. So as you can see, with every request, a new connection was being formed here, right, with these blue lines. But in persistent HTTP connections, the connection will not be created again and again. So as you can see, once DNS lookup happened, the client creates a connection with the web server. Then it sends a request, wait for the response, and the response came back after some time. Then client will use the same connection to send another request. So for this purpose, there was a header that was introduced in HTTP called connection with the value keep alive. So if the this header is sent in the request and response, it can be sent in the request and response as well. So if it is sent in the request, the client will tell the server not to close the TCP connection. It says to the server that I will be sending more requests, so please do not close the connection. So there is a by default timeout here as well. So for example, you can set up a timeout while maintaining the connection. You can just say like maintain this connection for 5 minutes. After 5 minutes, the connection will be dropped. If no request is made, after 5 minutes the connection will be dropped, and client will have to make a new connection again. So as a response header, when server send this header in the response, server replies with the same header to indicate that the connection is kept open. So when you will send this connection keep alive header in the request and server maintains the connection, then server will send the response with the same header again. So it just tells the client that connection is open and you can use the connection again. So as you can see in the diagram, the after DNS lookup with the same connection, multiple requests are going. Although they are serial, but the connection is not getting created again and again. Now another modification is parallel HTTP connection. So nowadays browsers can make parallel requests. Instead of waiting for a request to get finished before making another request, they can do it in parallel. For example, let's say you have two different web servers and you want to get the data from both of them. So in the previous diagrams, even if the servers are different, once the request from a server is completed, another request to another server will be made after that only. But in parallel HTTP connections, as you can see, these are independent. So browser can perform DNS lookup for both of them parallelly. So once the DNS lookup is done for both of them, it can initiate connection on both the servers indicated by these blue lines, and after the connection is done with both the servers, it can just make the request on both the servers in parallel. So as you can see, there are two web servers in the diagram, and after the connection is done on both the servers, the requests are being made in the parallel, not in a sequential manner. So requests can also go parallelly to the same web server as well. For example, here I've taken two web servers in the example in the diagram, but within one server as well, parallel requests can be made by the browser. So there is a limit though. So per domain, you mean for example, for this web server, only 6 parallel requests can be made by the browser at a time, and for this web server as well, the browser can make 6 parallel requests at a time. This is a by default limit set in most of the browsers. So Chrome, Safari, and Firefox, which are like most usable browsers, they all maintain a limit of 6 connections per domain. Please note that this limit is per domain. So if you have multiple web servers, so 6 parallel requests can go to this domain and 6 parallel requests can go to this domain. So problems with multiple TCP connection is like increased resource uses, for as many connections will be made in parallel, right, and multiple requests will be going in parallel. Obviously, so more resources, more CPU and memory will be used by the TCP connections. So redundant TCL handshake and slow start. So the TCL handshake are redundant. For example, when you make a web server, for example here, once the connection is dropped, it has to make the connection again, right, to make a new request. So there can be multiple redundant TCP connections with the same server as well. Also with the multiple servers, the number of TCP connections will increase. So there will be more congestion to control, and more congestion, and there will be there is not much control on this, especially with the weak networks. So with the weak networks, if you have observed, the sites become very slow, especially on the mobile, right? So this is the problem with the TCP. So another problem with TCP connection is head of line blocking. So in TCP, as you know, the data is sent in packets. For example, for a request, let's say three packets are being sent from client to server, one, two, three. So let's say the server received one and third packet, but somehow the second packet got lost. It didn't receive server didn't receive it. Then server will not transfer the first and third packet to the application until unless it receives the second packet. Right? It will wait for second packet, and if it doesn't come, it will just wait for it. So this is called head of line blocking, because of one packet, when the one packet is missing, the entire request is in waiting mode, right? So this creates a blocking. So this is the head of line blocking problem of TCP, and it will still exist in the HTTP as well, because HTTP 1.0 mostly works with TCP connections. So let's look into a concept of pipelining in HTTP. Pipelining is similar to persistent HTTP connection in the several HTTP requests, and several HTTP requests can be made before it is closed. So in pipelining, for example, let's look into the diagram. So here, as you see in the parallel HTTP connections, there were parallel requests being made by the server, right, to this server and to this server. And here the connection was being reused as well. So once the connection was made, this same connection was being used by the browser to send the subsequent request to the same server. So here as well, the same thing will happen. So here, after the DNS lookup is done, and the connection is made by the client to a web server, same thing will happen. The only difference is in the pipelining, all the requests will be made without waiting for the response of previous request. So here, as you could see, as you could see, uh, once the response came back, once the response came back for the previous request, only after that another request was being made to the server, right, to the same server. Here, uh, every request is made in parallel to the same server. So both the requests will go in parallel to the server, and client will wait for the response of both the request. And once the response is received for both the requests, the pipelining ends. So in the pipelining, it doesn't wait for a request to get completed before sending another. So in this, persistent HTTP connection is intended to set a complete HTTP request response pairs. With pipelining, several HTTP requests can be made without having to wait for a HTTP response, which ultimately reduce network latency. Because let's say here, if you will look into the latency, once first request goes, and then client waits for some time and gets the response for that. Then it makes another request and gets the response for that. So time that will take here to complete both the requests will be more as compared to the time taken by both the requests to get completed here, because here both the requests were made in parallel, like in pairs, and it will wait for let's say some time, and it will get the response for both the requests parallelly. So the total time to complete two requests here will be less as compared to the previous one. It is only limited to idempotent HTTP methods that includes HTTP GET, head, put, and delete methods. So we will look in detail what our idempotent methods are. If the message is lost, then the entire HTTP request can be resent without having to be concerned with side effects. So there are no side effects as well. So let's say if there is a failure, or if the message is lost, it can send the same request again without any side effects. But this is no longer being used in modern browsers right now, because it is a little bit complex to implement, because you have to send every request in one go and wait for it. So you will have to find out which response is for belongs to which request, and what if something fails. Then you have to handle all those complexities as well, right? So it is difficult to implement, and browsers nowadays have a parallel connections and much more than that, right? So it's not really useful to use it. So client must guess which resources are needed first. For example, in today's, let's say when you load a website, right? For example, when you go to a website, the first page load, you get a HTML response. Let's say you get HTML response and some JavaScript JavaScript scripts and some image URLs and all. So in that HTML, let's say some image URLs are embedded and there is some script files mentioned. So once you parse that HTML, the browser comes to know, right? They need these JS or image files as well to load the page fully. Then they request those JS scripts and images as well, right? But here, as you want to make use of pipelining, you have to guess what resources are needed by a page in advance, so that you can make all the requests like beforehand. So there is no feedback loop. So a response for a request can take a long time, and the client has no way of knowing like how long it will take. Head of line blocking, strict ordering of response is required. As I said, once you make a request, you have to figure out what response belongs to what request. So let's say this first request goes to the server, then you made another request. So response should also be in the order. So the first response that you will be receiving will be the response of first request that you made, because otherwise you will not be able to know which response belongs to which request, right? So response must reply in the same order as request. If that is not possible, then it will block the other request, right? For example, you are making three requests in parallel in this pipelining. Let's say the resource that is being loaded by the first request is huge, while the other two requests are very small. Then other two requests will keep on waiting for the first request to get completed, right? Like they will not proceed. So this becomes a bottleneck, and this is a head of line blocking problem in pipelining. This is also one of the major reasons it is not being used anymore. So in HTTP2, the replacement of pipelining is multiplexing. So I'll create a separate video on HTTP2, but in HTTP2, something called multiplexing has been introduced. So it works as a pipelining, but it does not it resolves the disadvantages here. It doesn't have an issue of head of line blocking. We will cover that part in HTTP2 only. HTTP1X protocol has forced browser vendors to introduce and maintain a connection pool of up to 6 TCP streams per host. As we already know, there can be maximum 6 TCP streams per host per domain. According to the HTTP archive, an average page is now composed of 90 plus individual resources. So the problem here is in the domain sharding. Right now, as web pages are getting bigger and bigger. So for example, if you go to a image loading web page, for example Pinterest and all those things, there are many images, right, on a web page. So on a page, there can be many individual resources that are needed by the web page, right? So all those resources need to be fetched from the server before loading the web page. So as you can have many resources, so on an average, according to a data, on an average there are 90 plus individual resources on a web page nowadays. And as we have a limit of 6 TCP connections per domain, right, in all the browsers, then getting all those resources will take some time, because you can you can only request for 6 resources at a time, right? And you have to get 90 plus resources to before loading the web page, so it will take some time. So to resolve that, some people use domain sharding. So in sharding, for example, you have a domain, for example, let's say example.com. Then you can create multiple subdomains, for example shard1.example.com or shard2.example.com and so on, and you can just divide your resources between them. For example, you can put 10 resources in shard1.com, next 10 resources, next 10 images in shard2example.com, next 10 resources in shard3example.com. So how this will benefit you? For example, this limit is per domain, right? So as you are using subdomain to get your resources, shard1example.com and shard2example.com is different domain for browser. So it will make 6 parallel requests to shard1, 6 parallel requests to shard2, and so on. So you will get you will be able to make more parallel requests and get your resources faster, but it will take more CPU and memory, and it will consume more resources as well. The problem here will be new hostname will require additional DNS lookup. So for each subdomain you are making a request, and an additional DNS lookup will happen, right, to get the location and all. And what there is no way to find out how many shards should be there. So if you over engineer them, so if you created too many shards, it will be difficult to you to manage the resources, because you have to manually manage the resources, like which image, for example, if you take example of different images, which image will sit on which subdomain, right? You have to manually manage that, and you have to take care of that, so that your clients request correct shard for that resource, right? And also, if you move resources, then you have to tell the client as well that resource has been moved to another subdomain. So in practical uses, what users have seen, this actually slows down the user experience because of TCP slow start and all these complexities. So people avoid using it, but in case of a small website, for example, for small lookups, you can use it. There is another approach that people use in HTTP to optimize the loading time of web page, or to get the resources faster, which is concatenation or sprinting. So in concatenation, multiple JavaScript and CSS files are combined into a single resource. So when you make a single request, you will get all the JavaScript and CSS files instead of getting a file and then finding out that you need another file from the script and something and fetch that. So you will just get all the files in a single resource, in a single request. In sprinting, let's say on your page you want different images. For example, you have different logos that you want to display on your page, and instead of creating a separate image for all those logos, you create just a single image with all those logos. So you just create a single image, and in that image all logos there are there side by side, and you download that huge image in one go. Instead of making requests for 6 different images, you just request for that single large image, and then you, depending on using your CSS and all, you display whatever logo you want on your screen. So this is called sprinting when is used with the images. So while combining the files into a single resource, we obviously eliminate the protocol overhead, like requesting each resource again and again. We just make a single request and we get all the data we want. But this introduces extra application complexity because additional processing is needed, right, to combine all the files or to combine all the images in a single image. And also, when client receives that, clients need to figure out like how to show a particular logo on a screen, right? You have to use some CSS tricks or something like that. So building multiple independent resources may also impact your caches. For example, on a page, you just want one of the image to be displayed on the screen, right? But as you are using sprinting, all the images will be loaded by your web page. So cache will be the data in the cache will be like not very useful because you have extra data in your cache. Plus, a web page may end up downloading the resources which it does not treat. For example, in case of images and CSS, if you are getting all the JavaScript and CSS on a page, the page might not be using all of them, right? Some of them might belong to some other page or route, right? So this is the problem with this. Page might end up downloading the resources which it does not need, and the complexity will be there to separate them out. So there is one more approach that is being used nowadays, which is like resource inlining. So I don't know, but you might have seen this kind of data, especially with the images in some of the HTML files, right? Which starts with data and then image GIF and all this encoded data. So here, what it does, the images are encoded in a string format, and that string is passed in this image tag image tag only. So here the image is specified in form of a raw data. Instead of a request is made to the server and the image is loaded from the server, right? The image is embedded here in HTML only. So it does not make a request in this case. From this data only, the browser can generate the image. So if the files are very small, for example, if your images are small and they are limited to specific pages, then you can consider inlining. For example, on your login page, you want to show some specific image that will not be shown on your other pages, right? Then you can consider inlining this small image on your login page. But if the files are frequently used across pages, then you have to consider bundling them instead of inlining them. Also, if the files have high update frequency, for example, if your images are getting updated again and again, then you can obviously not use this approach, right? Then you have to keep them separate and load from the server, because if they get separated, they need to be displayed on the client as well, right? So con here is the same thing. If the image changes frequently, then you cannot use the approach. It will be complex for you. Let's move into different HTTP methods that we use nowadays. The first method is simple get. This method is used by the client to get data. So it's always used to get some data. Another method is post. The post is a request type which sends some data to the server, and it asks server to perform some operation on that. So post is usually based to create some new entity on a server. For example, a new user is registering to your website, right? Then you have to create the entity for that user, right? So for that first request to create the user, you will use a post request. Put request is used to update the entity in the server. For example, input, you will send the whole JSON again. For example, let's say you have a user entity in your database which has his first name, last name, email address, and all those things, and you are using put to update the user info. For example, first name and last name only. You are updating the email. So instead of just sending email, you will just send all the info like first name, last name, and the updated email in the JSON form, and you will use put request to update the whole JSON for that user in the backend. While in patch method, you can just send whatever information you want to update. So input, as you send the whole JSON, but in patch you can just specify that I just want to update the email. So you will just send email colon the new email, and the server will just patch that information into the JSON. So patch is like input input the original object that was already there on the server is not mutated. It will create a new object and it will replace that with the existing object in the data store maybe. But in patch, it will just update the already existing object in the server. It will just go there and it will update the email there. In delete method, this is used to delete the entity on the server. For example, if a user unregistered from your website, right, you want to delete that info, right? So delete method is used for that. There are few methods that you might not have seen, but these are being used. So head method, this head method is used to get some metadata. So if you want to get some metadata information about the server on a resource or something, right, this method can be used for that. So option method, it's a option. If you go to network tab, usually when you make a request on most of the web servers, you will see there is a pre-flight call going there before any request made by the browser, which is options call. In options call, it's basically used to check what options are available for that particular domain or for that particular client on the server. For example, let's say server is not accepting a request. So you might have seen course error, right? So it's basically used for that purpose. So let's say server is not accepting a call from a particular client. Then when the client will make options call, the options call will fail, saying that it's not allowed. Then the browser will not make the actual request. It will just avoid the actual request, whether get or post. It will not make that. But if in the options, let's say in the pre-flight call, if the request is valid and everything is fine, it will make the actual request after that. There are two methods, trace and connect. So trace is basically used when we want to analyze something. We want to it's just for use for diagnostic purpose. Like I've not used this method in reality, but it's basically used for tracking purpose, like what is happening on the server. Here the connect method, this is used to make a connection. For example, instead of making a connection, when you want to make a request for a resource, you can use this method to make the connection in advance. So let's say that you will be getting data from some random server, and instead of waiting for the HTML file to load and then find out that you want some data from that server and making the connection, then you can in advance make the connection to that server, and when the browser will want to request the resource from that server, it will use the same connection. So to make a connection in advance, you can use this method. Now let's look into what are safe methods. A safe HTTP method can be thought as one of that is only read only. So the safe HTTP methods are get, head, options, and trace, because these methods are read only methods, right? When you get the data, you don't mutate any state on the server, right? Same with head, options, and trace. Like you just get the metadata in this case, and in this case you just find out if the request is valid or not. Similarly for tracing, you just get some info, right? You don't mutate any state on the server, right? So these methods are generally called safe methods, but actually that depends on the implementation as well. For example, we can do anything on the server, right? Let's say we are making a get request, but somehow on backend it's doing something on the DB, then it will not be a safe method anymore, right? So it also depends on the implementation. So generally it's not advisable to do any state mutation on these types of requests. So when you want to make the request safe, you use these methods. Idempotent methods are the methods that have identical outcome. For example, if they are called multiple times, the state will be same on the server. There will be no side effects, as you can see. So idempotent methods are get, head, options, trace, delete, and put. So as you can see, post is not there, right? For example, let's say post is used for creating a new resource, like your new user or new entity, right? So let's say you have created the entity once, you make the post request, and you created the entity successfully. Now if you will make the same post request again, the client will throw an error that it already exists. You cannot create a new entity with the same email or something like that, right? So this is not idempotent, because for multiple calls the outcome is different. But in case of put, as you are sending the whole object, so you put you use to update a resource, right? And you send the whole information about it. You like patch, you don't send a specific change, right? You just send the whole JSON again. So let's say there is a user, existing user on the server. You want to update the email from abc.com to bcd.com. So you put that whole JSON and you make the put request. Email will get updated on the server. Then if you will make that again, make that call again. The same thing will happen, a new object will be created on the server, but there will be no side effect, right? There will be no issue, like there will be no duplicated data, and every time you make a put request you will get the same response that the user has updated, right? Even with the same request body and everything, you will get the same response. So put is an idempotent method. If you are looking for patch, like if you want to say patch can be idempotent, but it depends on the implementation. Because let's take two scenarios. Let's say we are updating the email of a user. So let's say we are making patch calls again and again with the same email, let's say bcd.com. So every time the server will update the email to the will be updating the email to the same email, right? So there is no side effect, like every time you will get the same response, email updated. So in this scenario the patch is idempotent. But let's say you are making a transaction, so you are withdrawing an amount of, let's say, 10 rupees. So let's say you make a first patch call, right, and 10 rupees got deducted. Then you make another patch call, then 10 rupees got deducted again. But the total balance will keep on reducing, right? So state is getting updated. It's a side effect is being generated there. So patch is generally not put in idempotent methods, but it really depends on the implementation, how the implementation is done on the server side. Now, cacheable methods are the methods for which response can be cached by the browser. In the a cached HTTP response is the server return result that can be stored and referenced for the future. So whenever you make a get request or a head request, right? Mostly get and head requests are cacheable by default by the browser. So you can try it on the browser. Like when you make a request to a server, and you will just refresh the page. The next time will the same request will go, if the server is aligned caching for that resource, it will just return you another status. So first time, let's say you get a status code of 200 for the request. Next time you will get a uh, uh, 301 status code instead of 200, because now the content is being fetched from the cache, not from the server. So the data that is coming in get and head request are cacheable by default. Responses to HTTP post and patch requests may also be cacheable, but it depends on the options that are set in the headers of the request and response. let's look into different status codes that HTTP provides. So whenever a server sends a response to a client, it can use any of these status codes depending on the scenarios. So let's say 100 continuous status code. So most of the time you will be seeing a status codes from 2xx, 3xx, 4xx and 5xx category. So but there are codes which in 1xx category as well. So these are informational codes. So 100 says that you can continue. For example, you are getting some long resources, or you are streaming a video or something like that, or so server will server sends that sends this status code in the response to indicate the client that the session is progressing, like session is going on, and you can continue with your next step. You don't have to wait, you can continue with the next step. So this is used for that. 100 voice switching protocol is used when you switch the protocol in midway. For example, let's say you are using a HTTP connection, right? But you want to switch to WebSocket for some reason. Then you have to send two headers in the request. So one of the header is upgrade and another header is connection colon upgrade. So in the upgrade header, you will tell what protocol you want to switch to. For example, if you want to switch to HTTPS or maybe WebSocket or something else, then you can say upgrade colon WebSocket. You want to switch to WebSocket, and you want to tell the server that connection should be get upgraded to the WebSocket. So these both headers are mandatory to send when you are switching the protocols. And once the protocol is switched, server will send you a 101 status code indicating that a connection has been switched to WebSocket successfully, and you can use that now. Now these are the 2xx responses are usually the success response that indicates that your request has been successful. So 200 OK is generally used in get request, right? When you get some resource, so server will send you a 200 status code, and it will say that your request is successful and your resource is in the response. 201 created, it indicates that something gets created on the server. For example, by registering a new user, you want to create a new user entity in your server, right? So in that case, if the user is successfully created, server will return with the 201 status code. 202 accepted status code is generally used when server is taking a long time to process something. For example, let's say you have a shopping website and you want to assign some rewards to a user based on their shopping. For example, let's say if a user has shopped for more than 1000 rupees, you want to give them a reward. So you make a request to the server saying assign this reward to the user, and server is doing some processing on that, maybe doing something, and it's taking a long time. And so but you want your client, for example, clients will just send the request, and client wants to get the information from the server that the request is accepted, and it wants to continue with the data because reward will be assigned to that user in background, because reward allocation process is long and it will take some time. So what you can do, you can just use this status code. So when the request will go to the server will accept the request, it will start the processing, and it will return the response as 202 accepted, indicating the client that your request has been accepted and the reward allocation is started, and it will be completed in the background, and you can go on with your work. So in that case, 202 is written by the server. 204 no content is usually used when you query for a resource and that resource is not there. So for example, let's say a user has unregistered from your website and that data is deleted. Now if you want to query the information for that user, server will return with the 204 saying that this user is not there anymore. 206 partial content is usually used when you are fetching a large when you want to fetch a part of a resource. For example, let's say you are streaming a video, or you have a large data file and you want a small chunk of it. So in that case, HTTP response status is 206, indicating that this is not a complete resource, only a chunk of it. And in the HTTP headers, in the range header, this is a range header is used to indicate that what is the actual size of the resource and how much data is in the current response. So for example, let's say if a file is of 5 MB and you have got the chunk of from 2 MB to 3 MB, like the chunk between 2 MB to 3 MB. So in the range, it will tell you that you have got the data between 2 to 3 MB and total size is 5 MB. So in that case, when you get the partial data, like in video streaming and all, you get a 206 response. 207 multi-status response indicates that different processing is being happened. For example, let's say in a request there are multiple operations that a server needs to take. For example, it wants to create a user, it wants to create a login, it wants to do something else as well. So in a particular request there are multiple operations that needs to be performed before that request is successful, right? So let's say in multiple operations, let's say some of them were successful, like user was created, but credentials, let's storing credentials failed somehow. So half of the request was successful and half of the operations were failure, right? So in this scenario, because your request was neither successful or not, neither the complete failure, 207 multi-status is used, indicating that some of the tasks are successful but some are not, and in the server you can return a complete list of tasks that failed, so that user can try on them again. So 207 just indicates that your request is partially successful. Now if you move to 3x's redirection codes, so 300 multiple choices, it indicates that you have many choices on the response. For example, when you make a request, there can be if there are multiple responses for this, then the server will return it with the 300 multiple choices response, and the client can just choose what response he wants. 301 moved permanently. This is a status code which is written by the server to indicate that resource has been moved to a new location. So for example, let's say you have an image on a server and later on you have moved that image to some other location, some other web server or some CDN or something. Then when the request will go to the server for that image, it will just send you 301 saying that resource has been moved to the CDN or something permanently, and in the location header it will tell you the location where it has been moved, and client can make request to that new location. Similarly, 302 found is again uh, 302 move temporarily is the status code which is returned when the resource has been moved from the server temporarily. For example, let's say you are doing something on our server, and for that you have temporarily moved the resources to some other location. So for that purpose, that your resource has been moved to another location temporarily, and when you will make the request again, probably it will be available on the same server only. So for that scenario, 302 is written. It's actually not found, it's moved temporarily. Let me correct it. Yeah. Now 307 temporary redirect. So this is a status code like uh, which is like 302 only, temporary redirect, because here it says your resource has moved to some other location temporarily, and you can just redirect to that for the temporary amount of time to get the new resource. The difference here is 307 says that while redirecting to the new redirecting to the new location, your HTTP methods must remain same. So here it does not indicate anything like that, right? It just says your resource here it indicates that resource has been moved to another location temporarily, but here while making the request to another the new location, your method should not change, and method and body request should be same, only the location should change. So it's the response code for that. 308 is like 307 for 301. For example, 307 was for 302 to indicate that method and body should not change. 308 is for 301. So here it says again that resource has moved permanently to another location, and while requesting the new location, your method and body and request should remain same, only the location should change. Now let's move into the 4xx errors. 400 bad request indicates if a client is making some mistake while requesting making a request to the server. For example, let's say it's sending some data in the body which is not correct, which server does not accept. Then server can say that this is a bad body, the request is bad, and it will just return you 400 saying that something is wrong with the client and client should be responsible for examining the body or and debugging for debugging purpose, and it should send the correct request next time. 401 unauthorized is a response which is sent when the user is not authorized. For example, your most in a website, like some pages are behind login pages. So if a user is not logged in and is trying to access those pages, then if the credentials are not valid, for example, if you're logging to Amazon account, right? If you want, there's a if you have a login to Amazon account and you have put incorrect password, then you will receive a 401 saying that you are unauthorized because your credentials are wrong. So it just says you are not authorized to access the resource. 403 forbidden says it's same thing, like you're not um, you're not allowed to access the resource. So difference between 401 and 403 is, in 401 it says their credentials are wrong. So next time when you will provide the correct credentials, you will be able to access the resource. But in 403, it's like a role based access. For example, your credentials could be correct, but because your role is different, like you are not admin of a website, you will not be able to access some things. So in that case, you will get a forbidden message that your credentials are correct, but you are not allowed to access the resource. 404 is not found. Again, like when something is not there, uh, then then you can say 404. 404, for example, again, if a user is not there and if you are querying for that user, server will return you with the 404. So people get confused with 204 and 404 here. So because 204 here says no content, but the difference here is the request here is successful. For example, let's take a scenario. If you want to delete a user from your server, the first time you make the request, delete is successful. Next time you make a request, because the user is not there, right, already deleted, so the request is successful because deletion is already happened. It's just a duplicate request you are making. So the server will respond with 204 that the content you are trying to delete is not there. It's already done. So it's a request is successful and 204 will be sent. But here 404 means request is not even there. For example, let's say you are querying a user which is not there. So you want the info for it, but it's not even available there. In that case, it's a error response, right? You are querying something which is not there. So 404 will be written. 405 method not allows is used when user is trying to use a HTTP method which is not supported by a server. For example, for a particular response, for a particular resource, only post method is allowed. For example, you want to create something on the server, and for that you have just enabled post method on a particular endpoint. So if you will use any other method like get or any other method on that endpoint, you will get a 405 that this method is not allowed. 429 too many requests, it is used to indicate that a server is overloaded with many requests and it will not accept any request anymore. So in that scenario, when you have rate limiting, if you have heard about rate limiting, so once the limit of the request is reached, that can be accommodated by the server will start throwing 429 saying that you should stop sending more requests because server is not able to handle these many requests and try after some time. Now the 5xx server error codes, 500 internal server error, it's a generic error message. For example, for some reason if you are not aware what failed on your for your request on the server, right, you can just return with the 500 internal server error saying a generic error message. 502 bad gateway, it just says that if the server is depending on uh, if the server is depending on another stream, so it just indicates that a server is acting like a gateway. So it's waiting for a response from another server from another service, and it's not receiving a valid response from there. So in that case, you can say that I'm just acting as a proxy for that service and I have not received any valid response from that. So 502 bad gateway will be written. 503 service unavailable indicates that server is not even available to the client. For example, in this scenario, when you are not receiving a response from your downstream services, then you say 502 gateway bad gateway, but if the server is itself is down, then 503 service unavailable is written from the server. 504 timeout is something when you are, for example, client made a request to the server, and let's say by default the time limit for waiting period is 10 seconds. So after 10 seconds, if the request has not yet received the response, then it will fail with 504 gateway timeout, saying that timeout has occurred and we have not still received the response for the request. So client should try again. 507 insufficient storage says if there are lack of storage on the server. For example, you are storing data in memory. After some time your memory will be full, right? You will be having, we will not have sufficient storage to add more data to it. In that case, you can just send 507 as a response. So limitations of HTTP 1, as we have already seen, it's a head of line blocking. It just waits on a request before sending another request. It waits for the first request, and TCP head of line of blocking is also there. So head of line blocking is generally there in HTTP 1. So from HTTP, we using parallel connections, we can remove the blocking part, but TCP head of line blocking is still there. So no matter use parallel connection, persistent connection, or any other approach, until unless you are using TCP as an underlying protocol, TCP head of line blocking will still be there. Redundant headers. So as there are many headers in HTTP 1.0, there can be redundant headers. For example, by mistake client can send two content. So there is a header called content length that indicates how much length the response or the request data has. What is the length of the data that is being sent? By mistake client can send two content length header and with different values, right? So that will be redundant header problem. It can occur in HTTP. There can be many TCP connections opened by the browser because the limit is per domain, and if you want resources from different domains, then can be many TCP connections made by the browser. On high latency networks, slow loading. Loading can be really slow on high latency networks because if the latency is high, right? Because the response is taking time, your page load will take more time, right? So slow loading will be there. So client will need to use multiple connections to achieve concurrency and reduce latency. So for parallel connections, as again, or for to connect to different servers, you need to open different connections, right? For each server, you have to request another connection, right? So clients need to use multiple connections to achieve concurrency here. Here there is no compression of request and response header. They are like sent as a text message. So if you will open the network tab on your browser, right, you will see there is no encoded format being sent to the server or received from the server. Whatever you type there as a text, it just goes there. There is no effective resource prioritizing, resulting in poor use of underlying TCP connection. For example, if you want to prioritize your resource, for example, let's say there are many images on the server and you want to prioritize something. Let's say for example, background image should load first, then the other images, right? Then there are ways to prioritize these things using resource hunting and all, but there is no very effective way to prioritize the resource. Like in HTTP 2 and HTTP 3, there is a complete different approach to prioritize things. So that we will see there. But here there is no really very effective way to prioritize all the resource, and it results in poor use of underlying TCP connection. Okay, that is all for today's video. I will cover the demo of this HTTP in a separate video. So I have created very small demos with all these concepts like domain sharding and serial connection, parallel connection, and all these things. And I'll cover all of them in a separate video because this video is already getting very long. Till that time, thank you for watching this, and please like, share, and subscribe.